Hey guys, today we are going to do 3-5 systems with 3 variables. So you will be able to solve systems in 3 variables using elimination and substitution. The big idea, to solve systems of 3 equations in 3 variables, you can use some of the same algebraic methods we use to solve systems of 2 equations in 2 variables. You can use the elimination and substitution methods to solve a system of 3 equations in 3 variables by working with equations in pairs. You will use one of the equations twice. When one point represents the solution of a system of equations in 3 variables, write it as an ordered triple instead of an ordered pair, x, y, z. So, problem number 1, we are going to solve this system using elimination. Step 1, we are going to pair the equations to eliminate z. Then you will have 2 equations in x and y. So first we're going to have 1 and 2. (2x plus 3x plus x is 3x. Negative y plus 3y is plus 2y. And z plus negative z cancels, and we are left is equal to 15. And we can also subtract. So we're going to do 2 and 3 now. So x minus 4x is negative 3x. 3y minus y is plus 2y. Negative z minus negative z cancels. And we are left with 11 minus 14, which is negative 3. Now we are going to write the 2 equations as a system, and we are going to solve for y. So we have 3x plus 2y is equal to 15, and negative 3x plus 2y is equal to negative 3. We're going to add these 2 equations that we just made. 3x minus 3y, 3x cancels. 2y plus 2y is 4y. 15 plus negative 3 is 12. Solve for y. And y is equal to 3. Since y is equal to 3, we are then going to substitute y equals 3 and solve for x. So, we are going to solve for x. 3x plus 2 times 3 is equal to 15. And subtract 6. 3x is equal to 9. Divide by 3. X is equal to 3. Now we are going to solve for z, so we have to substitute the values of x and y into one of the original equations. So let's look back at our original equation, and I'm just going to take that first equation, 2x minus y plus z equals 4. Substitute 3 in for x and y. Two times 3 is 6, minus 3 is 3, so 3 plus z equals 4. Subtract 3 from both sides, and z is equal to 1. So we are going to write the solution as an ordered triple. We said before that was going to look like x, y, z. So our solution is 3, 3, 1. You can apply the method in problem 1 to most systems of 3 equations in 3 variables. You may need to multiply, however, in 1, 2, or all 3 equations by 1, 2, or 3 non-zero numbers or constants. Your goal is to obtain a system equivalent to the original system with coefficients that allow for the easy elimination of variables. You can also use substitution to solve a system of 3 equations. Substitution is the best method to use when you can easily solve for one of the equations for a single variable. So, we are going to solve the system of equations. We are looking at our 3 equations, and I see equation 2 would be easiest to solve for x. So, x plus 5y is equal to 9. I'm going to subtract 5y from both sides. And x is equal to negative 5y plus 9. We are then going to substitute the expression for x into equations 1 and 3. So, 2 times, instead of x, I'm going to write negative 5y plus 9 plus 3y minus 2z is equal to negative 1. And in equation 3, I'm going to write 4z minus 5 times, not x, but negative 5y plus 9 is equal to 4. Simplify both of those equations. Once you solve those, you simplified both of those equations, we are going to write our 2 new equations as a system and solve for x, y. So we have negative 7y minus 2z is equal to negative 19, and 4z plus 25y, I'm just lining up the variables, is equal to 49. I think it's easiest to multiply our top equation by 2 so that we can cancel our z's. Going to have negative 14y minus 4z is equal to negative 38. Keep our second equation. Add the 2 equations. So we have negative 14y plus 25y is 9y. I'm lying to you. That is 11y. The z's cancel, and negative 38 plus 49 is 11. Divide by 11. Y is equal to 1. Now take 1 and plug it in to solve for z. Negative 7 times 1 minus 2z is equal to negative 19. Negative 7 minus 2z equals negative 19. Add 7. Divide by negative 2. Z is equal to 6. Now we use one of our original equations to solve for x. So I'm going to look back and see 2x plus 3y minus 2z equals negative 1. So 2x plus 3y minus 2z equals negative 1. Plug in what I know. 2x plus 3 times 1 minus 2 times 6 equals negative 1. 2x plus 3 minus 12 equals negative 1. 2x minus 9 equals negative 1. Add 9. 2x is equal to 8. Divide by 2. X is equal to 4. Y is equal to 1. Z is equal to 6. Therefore, we have 4, 1, 6 as my solution. That's all.